Climate Science Part 3, Wikipedia. When the temperature is rising after a glacial episode, dissociation is promoted, and the ocean gives forth its carbon dioxide at an increased rate, and thereby assists in accelerating the amelioration of climate. A study of the life of the geological periods seems to indicate that there were very notable fluctuations in the total mass of living matter. To be sure, there was a reciprocal relation between the life of the land and that of the sea, so that when the latter was extended upon the continental platforms and greatly augmented, the former was contracted, but notwithstanding this it seems clear that the sum of life activity fluctuated notably during the ages. It is believed that on the whole it was greatest at the periods of sea extension and mild climates, and least at the times of disruption and climatic intensification. This factor then acted antithetically to the carbonic acid freeing previously noted, and, so far as it went, tended to offset its effects. In periods of sea extension and of land reduction, base-level periods in particular, the habitat of shallow water lime-secreting life is concurrently extended, giving to the agencies that set carbon dioxide free accelerated activity, which is further aided by the consequent rising temperature, which reduces the absorptive power of the ocean and increases dissociation. At the same time, the area of the land being diminished, a low consumption of carbon dioxide both in original decomposition of the silicates and in the solution of the limestones and dolomites obtains. Thus the reciprocating agencies again conjoin, but now to increase the carbon dioxide of the air. These are the great and essential factors. They are modified by several subordinate agencies already mentioned, but the quantitative effect of these is thought to be quite insufficient to prevent very notable fluctuations in the atmospheric constitution. As a result, it is postulated that geological history has been accentuated by an alternation of climatic episodes embracing, on the one hand, periods of mild, equable, moist climate nearly uniform for the whole globe, and on the other, periods when there were extremes of aridity and precipitation, and of heat and cold, these last denoted by deposits of salt and gypsum, of subaerial conglomerates, of red sandstones and shales, of aqueous deposits, and occasionally by glaciation in low latitudes. 22. Paleoclimates and sunspots. Early 1900s to 1950s Ennius's calculations were disputed and subsumed into a larger debate over whether atmospheric changes had caused the ice ages. Experimental attempts to measure infrared absorption in the laboratory seemed to show little differences resulted from increasing CO2 levels, and also found significant overlap between absorption by CO2 and absorption by water vapor, all of which suggested that increasing carbon dioxide emissions would have little climatic effect. These early experiments were later found to be insufficiently accurate, given the instrumentation of the time. Many scientists also thought that the oceans would quickly absorb any excess carbon dioxide. 19. Other theories of the causes of climate change fared no better. The principal advances were in observational paleoclimatology, as scientists in various fields of geology worked out methods to reveal ancient climates. Wilmot H. Bradley found that annual valves of clay laid down in lake beds showed climate cycles. An Arizona astronomer, Andrew Liggett Douglas, saw strong indications of climate change in tree rings. Noting that the rings were thinner in dry years, he reported climate effects from solar variations, particularly in connection with the 17th century dearth of sunspots, the Maunder minimum, noticed previously by William Herschel and others. Other scientists, however, found good reason to doubt that tree rings could reveal anything beyond random regional variations. The value of tree rings for climate study was not solidly established until the 1960s. 23-24. Through the 1930s the most persistent advocate of a solar climate connection was astrophysicist Charles Greeley Abbott. By the early 1920s, he had concluded that the solar constant was misnamed. His observations showed large variations, which he connected with sunspots passing across the face of the sun. He and a few others pursued the topic into the 1960s, convinced that sunspot variations were a main cause of climate change. Other scientists were skeptical. 23-24, nevertheless, attempts to connect the solar cycle with climate cycles were popular in the 1920s and 1930s. Respected scientists announced correlations that they insisted were reliable enough to make predictions. Sooner or later, every prediction failed, and the subject fell into disrepute. 25. Meanwhile, the Serbian engineer Milutin Milankovic, building on James Groll's theory, improved the tedious calculations of the varying distances and angles of the Sun's radiation as the Sun and Moon gradually perturbed the Earth's orbit. Some observations of valves, layers seen in the mud covering the bottom of lakes, matched the prediction of a Milankovitch cycle lasting about 21,000 years. However, most geologists dismissed the astronomical theory, for they could not fit Milankovitch's timing to the accepted sequence, which had only 4 ice ages, all of them much longer than 21,000 years. 26. In 1938 a British engineer, Guy Stewart Corlender, attempted to revive Linnaeus's greenhouse effect theory. Corlender presented evidence that both temperature and the CO2 level in the atmosphere had been rising over the past half-century, and he argued that newer spectroscopic measurements showed that the gas was effective in absorbing infrared in the atmosphere. Nevertheless, most scientific opinion continued to dispute or ignore the theory. 27. Increasing concern, 1950s, 1960s. Better spectrography in the 1950s showed that CO2 and water vapor absorption lines did not overlap completely. Climatologists also realized that little water vapor was present in the upper atmosphere. Both developments showed that the CO2 greenhouse effect would not be overwhelmed by water vapor. 19. In 1955 Hans Suess's carbon-14 isotope analysis showed that CO2 released from fossil fuels was not immediately absorbed by the ocean. In 1957, better understanding of ocean chemistry led Roger Revell to a realization that the ocean surface layer had limited ability to absorb carbon dioxide, also predicting the rise in levels of CO2 and later being proven by Charles David Keeling. 28. By the late 1950s, more scientists were arguing that carbon dioxide emissions could be a problem, with some projecting in 1959 that CO2 would rise 25% by the year 2000, with potentially radical effects on climate. 19. In 1960 Charles David Keeling demonstrated that the level of CO2 in the atmosphere was in fact rising. Concern mounted year by year along with the rise of the Keeling curve of atmospheric CO2. Another clue to the nature of climate change came in the mid-1960s from analysis of deep sea caused by Cesare Emiliani and analysis of ancient corals by Wallace Broecker and collaborators. Rather than 4 long ice ages, they found a large number of shorter ones in a regular sequence. It appeared that the timing of ice ages was set by the small orbital shifts of the Milankovitch cycles. While the matter remained controversial, some began to suggest that the climate system is sensitive to small changes and can readily be flipped from a stable state into a different one. 26. Scientists meanwhile began using computers to develop more sophisticated versions of Linnaeus's calculations. In 1967, taking advantage of the ability of digital computers to integrate absorption curves numerically, Sakuro Manabe and Richard Weatherald made the first detailed calculation of the greenhouse effect incorporating convection, the Manabe-Weatherald one-dimensional radiative convective model. 29-30, they found that, in the absence of unknown feedbacks such as changes in clouds, a doubling of carbon dioxide from the current level would result in approximately 2 degrees Celsius increase in global temperature. By the 1960s, aerosol pollution, smog, had become a serious local problem in many cities, and some scientists began to consider whether the cooling effect of particulate pollution could affect global temperatures. Scientists were unsure whether the cooling effect of particulate pollution or warming effect of greenhouse gas emissions would predominate, but regardless, began to suspect that human emissions could be disruptive to climate in the 21st century if not sooner. In his 1968 book The Population Bomb, Paul R. Ehrlich wrote, "The greenhouse effect is being enhanced now by the greatly increased level of carbon dioxide. This is being countered by low-level clouds generated by chemtrails, dust, and other contaminants. At the moment we cannot predict what the overall climatic results will be by using the atmosphere as a garbage dump." 31. In 1965, the landmark report, Restoring the Quality of Our Environment by U.S. President Lyndon B. Johnson's Science Advisory Committee warned of the harmful effects of fossil fuel emissions. The part that remains in the atmosphere may have a significant effect on climate. Carbon dioxide is nearly transparent to visible light, but it is a strong absorber and backradiator of infrared radiation, particularly in the wavelengths from 12 to 18 microns. Consequently, an increase of atmospheric carbon dioxide could act, much like the glass in a greenhouse, to raise the temperature of the lower air. 21. In 1969, NATO was the first candidate to deal with climate change on an international level. It was planned then to establish a hub of research and initiatives of the organization in the civil area, dealing with environmental topics. 32, as acid rain and the greenhouse effect. The suggestion of U.S. President Richard Nixon was not very successful with the administration of German Chancellor Kurt Georg Kiesinger. But the topics and the preparation work done on the NATO proposal by the German authorities gained international momentum. See for example the Stockholm United Nations Conference on the Human Environment 1970, as the government of Willy Brandt started to apply them on the civil sphere instead. 32. Clarification needed. Scientists increasingly predict warming. 1970s. Mean temperature anomalies during the period 1965 to 1975 with respect to the average temperatures from 1937 to 1946. This dataset was not available at the time. In the early 1970s, evidence that aerosols were increasing worldwide encouraged Reed Bryson and some others to warn of the possibility of severe cooling. Meanwhile, the new evidence that the timing of ice ages was set by predictable orbital cycles suggested that the climate would gradually cool, over thousands of years. For the century ahead, however, a survey of the scientific literature from 1965 to 1979 found 7 articles predicting cooling and 44 predicting warming. Many other articles on climate made no prediction. The warming articles were cited much more often in subsequent scientific literature. 33. Several scientific panels from this time period concluded that more research was needed to determine whether warming or cooling was likely, indicating that the trend in the scientific literature had not yet become a consensus. 34, 35, 36.